Okay, so this is our last talk of the evening. We'll have some time for Q&A afterwards. But I'm very happy to introduce somebody I've known a long time in the world of search. He attempted to retire from the world of search. He's crept back. He's not hiring, no. But please welcome Mark Harwood.
Thanks, Charlie, and thanks for putting all this together as well. So tonight I wanted to talk about a thing that I chose to call Emergent Facets. So just as Charlie said, a little background, I was an early Lucene contributor. So back when it was on SourceForge, if anybody remembers that. Maybe Charlie remember that. I was lucky enough to join Elastic quite early on, mainly as part of the contributions that I've been working with on Lucene. And since retiring from Elastic, I'm mostly a man of leisure, but tinkering on various different things, which I'll present here tonight. So just to give some background, we're all familiar with facets and we use them all the time. So we have something like Amazon, and essentially what we're trying to do is put everything in boxes. So trying to define boxes and put things in them for the convenience of then being able to narrow down and our searches and so on. So this is the typical experience of your e-commerce search engine, and it typically relies on pre-index fields. So the data is very curated and very structured. So there are teams of people who think about what's involved. Nowadays, I suppose some of this stuff you can hand over to AI, but conventionally people have had to sort of worry about, well, how many different fields do we need? How many different facets have we got? What are the acceptable values? So it's very much like a controlled vocabulary. And then for each document, you then have to decide what values does it have and assign all these documents with the appropriate values to then be able to do your faceted search interface. And a lot of what goes on behind the scenes here is to actually make the decision-making and the search process actually simple. So under the covers, we tend to be using search engines that have sort of full Boolean capabilities, your Vespers, your Elasticsearch, your Open Searches. Sounds like birds. Oh, okay. Now, implicit in this screen, there's a lot of stuff that's hard-coded. So there's the idea at the top, we have our text search, so people are typing in whatever they like in there, typically not using ands and ors and nots and things. They don't tend to know what those features are. So they'll just type in keywords. And then on the left here, we have the facets, which are then used to filter, which is typically an and. So you can pick a color, so like blue, and it must be leather shoes, for example. But within this, there is some subtlety. So when we pick what are we saying, a material here, so we've got leather and canvas and things like that. Typically, we're oring those items. And the user doesn't have control. So maybe they wanted to and it. Maybe they wanted something with leather and mesh. But they don't have the opportunity to articulate that as part of their query. So it's quite a curated experience. And it works fine for these sort of systems and these very well-known, well-understood data sets with people who are working round the clock to actually provide this kind of interface. What I wanted to talk about was not those environments, so different environments where the world is moving much faster than the ability for people to come along and add the structure into the system. So to create all those index fields and control the vocabularies and so on. So there's a number of examples where we have sort of fast-moving spaces where content is changing all the time. So we have things like breaking news, social media, new terms are coming into play all the time, new ideas, like in the form of patents and things like that. By design, people are actually trying to invent new things that are unique. So in the world of patents, we're always seeing new things emerging all the time. The same is true in the world of scientific papers and startups and things like that. So these sort of environments are much harder to provide these kind of faceted search interfaces on. And that's where the topic of my talk comes in. So I wanted to present two examples that I found useful. Optionally, a third example, which I haven't chose to show here, which is an older one. The the two sort of newer ones that I've been playing with recently are binary vector clustering and LLM generated tags. And we'll dive down a bit deeper into how these things work. But just at a high level, just to compare the two techniques, I would describe and characterize them as binary vector clustering is fast and cheap. It's a quick and effective way to actually group things, put things into boxes which haven't previously been considered. And the LLM generated tags is much slower, much more costly to go about doing. So it's not something you would put on a high traffic site, for example. But if you had, a limited number of users with very important work to be done, like patent searchers, then that might be an appropriate technique to employ here. And when we introduce these, what I'm calling emergent facets over here on the right, we're adding those alongside all those traditional interfaces. So we have our text search box, we have our conventional facets, and now we have this new part of the vocabulary, these other artifacts that people can pick up and then interact with. So we all know how to interact with Amazon. We type in our search box and we click some checkboxes down the side. But the question is, how do we begin to make use of these other facets that are emerging, where we might want some flexibility as to how we combine these elements? So just taking the first two conventional examples on the left here, somebody's done a search for dog lead in a patent database. And down the bottom, we have a bunch of facets that have been generated. So category codes, if you like. If you've done anything with patents before now, you'll know about IPC codes, CPC codes. So they try and give unique numbers to each unique subject in a big ontology. And not everything always is labeled as you would hope, because data is never perfect. So if you go to the site lens.org, which has all the patents in the world in there, you can use the sort of Amazon type interface where you can search for dog and lead, and then you can click on the checkbox down the bottom there that's AK37402, whatever it is, which is dog leads. And that will do an and. And they recognize that that isn't always sufficient, because sometimes there are patents that didn't use the category code or use the words dog and lead. So they want to be able, people want to be able to order these things, the patent searchers. So that's why they have this fallback to using Lucene query syntax. How many people are familiar with Lucene query syntax or thereabouts? Yeah, unfortunately, yeah. It's horrible. You have to write ands and ors and brackets and all those kinds of things, and it's very hard to debug, and it's not very nice. So that was my frustration with these kind of interfaces, even before Emergent Facets came along, was that I was looking for more flexible ways to combine these forms of input. And now we have these other features here. The big question mark in the middle is, how do we combine all these things? And that's part of what I've been working on for a number of years, is a language, a new visual language that allows people to combine all these elements together and make use of all those Boolean logic filtering features that we have in all of our databases. So the Vespa, the Elasticsearch, Postgres, all those things. So let's talk about the first form of emergent faceting. So that's binary vector clustering. And this is an example which I'll demonstrate in a little while. It's one application where we have the latest headlines. And we have lots of different newspapers all talking about the topic of the day. And if we sorted them chronologically, then we'd have a mix of various different things as they came in. Using binary vectors, we can cluster them on the fly and organize them into groups. And this is done just by using vector embeddings. So obviously we're familiar with things like floating point vectors. You can compare two documents' similarity using these various different distance measures. If we're using binary vectors down the bottom, then we can use a Hamming distance measure to say how similar are these two documents. And that's the basis of how we cluster, is we compare the similarity of every single document in the search result. And why binary vectors in particular? Well, I think these are small enough and good enough to send down to clients. And by clients, I mean, desktop computers or mobile phones even. So my old iPhone, which is an iPhone 10, I think it was perfectly capable of ripping through and clustering, hundreds of articles sub-second as I scrolled a slider. It's very quick. So you just have to do a simple XOR and population count to compute the distance. And in my experience, the quality is pretty good. I've never come across like a false positive when I've had a match or clustered two things together. I've never had cause for complaint personally. So I've found them good enough in principle. I haven't done any particular benchmarking on this to do scientific benchmarking, but just from a user experience point of view, I found them perfectly good or good enough. So the way it works, we've got a sort of form of graph visualization here. We've taken 4 or 5 search results here, and we've computed the similarity between all of them. And that's a graph. So between each pair of documents, we have a line. And the line thickness in this diagram represents the similarity. So what my slider here does is as we move the slider, we basically cut the weak lines. And if you cut the weak lines here, you might end up with 2 clusters, the 2 documents at the top and then 3 at the bottom. So that's all I'm doing when I'm moving the slider in my demos, is I'm actually just filtering out weak connections between the documents, and I end up with these nicely organized clusters of all the various different news articles. And one of the interesting things about these clusters, once you have them, so you might see a cluster here in the middle, and it's a topic that you might be interested in. So you can take, as an end user, you can say, I want to drill in on that topic, that news subject. So on the fly, what we can do is we can take the vectors of all those documents that fall into that cluster, and we can merge them in JavaScript, on any device in your browser, and end up with a perfectly functional and very useful summarization of all those component elements. So this has utility. This is useful for taking that and expressing my interests. I'm not using keyword search. I'm just picking up a group of documents that have been clustered together as semantically similar, and I'm saying that's what I'm interested in. I want to look at that. So when I first started doing this, I thought, well, this is really useful, and I want to have something that's emblematic of that cluster. I want something that I can click on to say that's the cluster I'm interested in, and narrow down on it. And I also wanted to see what the magic was that was going on inside this. So I started visualizing the bits in the binary vectors. So we end up with this funny little code here, which looks a bit like a QR code. And the thought then occurred to me that actually perhaps we should train users to recognize these things in the same way that users currently see a QR code and immediately know, oh, I've got to scan that and then I'll get the menu in the restaurant or whatever it is. So, my mum now knows that she sees a QR code. Boom, she knows this, she's not meant to understand it, but she knows that it has utility and she does something with it. I was hoping that we could start to maybe introduce that into the lexicon of how people converse with search engines. They can start to see these things and go, I know that's a query item, and put it into my query. So I have a little user-facing website called qry.codes, and it's designed to teach my mother and your mothers and everybody else what these things are and how magical they are, and the fact that you can merge them and group them and cluster them with sliders and things, and they actually are very useful ways of articulating what you're looking for without having to use words. So searching using pictures. Interesting concept. Another example of where you can get these things from other than clustering. So here I've done a little bit of RAG on a set of search results. I've done a query for, I can't remember what it was, fires in Los Angeles, I think it was. And then I asked an LLM to give me a summary of all the articles that I matched. And one of the things it pulled out was the fact that there were incidents of people impersonating fire officers and looting. And the way I instructed the RAG to present results back to me is because they can hallucinate and everything else. I wanted to make it grounded. So in my search interface, I said, whenever you make an assertion, give me the citations, give me the actual document IDs that support this assertion of yours. People were dressing up as fire officers. When I click on these numbers here, which are, result 19, 20, 25, and 42 in my search results talked about this, I see them listed below. And that in itself is a little cluster, which I can then merge all those embeddings and then pick up a single embedding at the top there, which is the fused representation of that. And I can use that as a query to say, find me stuff about people impersonating fire officers and looting. So the second thing that I want to demonstrate tonight was LLM-based tagging. And it's another form of emergent faceting. And what it does is we ask the LLM to look at search results and then add tags to our documents. So the tags in yellow there are for a patent, which is to do with a travel guitar, a collapsible guitar. And it's introduced some tags there saying has collapsible body, is acoustic instrument. So it's added those tags, and they're similar to the other tags that we see below, a little bit more understandable perhaps. So somebody in a patent office somewhere assigned the CPC codes G100, 108 or whatever it was to these documents here. The ones in yellow were ones that were added by an LLM at query time. And the way in which you can render these things, you can render them as tags on individual documents, but you can look at them in aggregate as well, in these kind of ways. So you can, for a set of documents, have a bunch of features that have just been invented by the LLM, and we have a feature comparison matrix now. So rather than reading 200 patents and then trying to invent boxes in my head for how to organize them, the LLM's read through them and come up with a set of features that it thinks are a good way of breaking down topics that these things cover. Or another way of presenting the same information is using a graph-based visualization. So you can show the tags and all the documents that have those things, so you can see which documents have multiple features much more easily and cluster them and so on. So those are the two sort of representations that I've used in my demos here. Getting the LLM to come up with useful tags was a bit of an exercise. So when I first started, I said to the LLM as a prompt, here's a bunch of search results about a particular topic, where the user's done a search. Please try and come up with useful tags. And for each document that you tag, please try and make sure that you're consistent in your use of terminology or tagging. So it would go away and it would look at a bunch of patents, and it would say patent number 1 has multiple, it's for dog leashes, so it has multiple attachments for multiple animals. So has multiple animal support would be one of the tags that it invented. On the very next patent, it then might come up with another tag, which was as support for 2 dogs or something like that. So very, very similar, but didn't rationalize the choice of tags that it was coming up with. So the better strategy that I came up with for trying to coerce this LLM into doing what I wanted was to tell it, imagine you're playing the game of Guess Who. So if you're familiar with the game, the best strategy is you're trying to pick out features that are highly discriminative. So the best strategy is to find something which splits the result set exactly 50-50 down the middle. So is male, is female, is wearing a hat, is wearing glasses, those kinds of things. So the LLM is asked to come up with the features first and then assign the documents as to whether or not they had that feature. That's the much better strategy. It also means that you can have one LLM come up with the set of features, and then you can have multiple LLMs validate that, yes, it is true that this document has that feature. So if you simplify it down to just Boolean values, does it have this feature, yes or no, for a given document, then you get all that goodness. So let's have a look at these two things in action. Any questions before I move on? Okay. Right. So this is my news demo. This is data going back, I suppose it's about 4 or 5 years, news headlines. But what we're showing here is the latest 200 or so latest items that happened in the news. I haven't got a query at this point. I've got all the stuff stored in Elasticsearch, but the query interface in this application is designed to work with Elasticsearch, OpenSearch, Vespa, Redis at a push. So basically, a lot of the search engines out there talk the same language. They do Boolean logic, they do binary querying and all that sort of stuff, binary vectors and stuff. All of the stuff that I'm showing now is basically just JavaScript running in my browser. So if I move this slider all the way to the left, then I end up with one very broad category where everything is matched into one big pile. So these are the latest 200 documents, and we can basically scroll through them all, and it's basically probably overlinked everything here. At the other extreme, we go all the way to the other end. We flatten it out, so we have 200 articles, each in a cluster of just one. And somewhere in the middle is kind of the sweet spot. So this is where we're seeing televangelist Jimmy Swaggart has just died at the age of 90. Differences over policy, Trump and Musk are at it again. So that's Trump and Musk stuff. So for each one of these things, you can pick up that vector and drop it into your query builder like that as the first level of filtering. And I've just realized I may have lost my internet connection. It hasn't filtered. Bear with me a second. All right. Oh, the check guest thing isn't working, so I'm having to use my iPhone here. All right, let's call that on. Okay, there we go. So this was my vector query, and we have various Trump and Musk feuds sorted by similarity. So that is using Elasticsearch at that point. So we've narrowed the query down. But all the stuff about organizing results into clusters, that's all happening in JavaScript on the client and grouping things together. One example of how you would use this stuff, I'm going to use a keyword query now. So I'm using Elasticsearch to do just a query for, let's say, ICE. So we're interested in, that's obviously hugely topical in the US at the moment. So if we search for ICE, we get a bunch of things here to do with documents that contain the word ICE. And at this moment, it's not particularly discriminatory because its top result is something that mentions ICE twice. So this is sort of BN25 working there. So I haven't given it any indication as to whether or not I'm interested in ice hockey, snow and ice, or ice, as in terms of deporting people and things like that. And this is where this clustering thing comes in useful again. So obviously, there's an issue with using some lexical matching here. The word ice is ambiguous and it can match multiple things. So as a user, to clarify my intent, if I group these things by topic, again, I can use the slider here to group things together. So we have a cluster forming here on the left, 31 matches in it. Deported, kidnapper, people arrested by ICE, that sort of thing. Whereas the next cluster here is UK braced for further snow and ice and that sort of stuff, US, snow and ice. I don't have to be particularly picky with this. I can just group a bunch of things together and then say, well, now I want to use that as a query term. So I'm dropping it into my query builder here. And the way the query builder works, it supports arbitrarily complex Boolean logic. It's quite simple in that it just lays things out from left to right. So if you go arrange things horizontally, they're ands. And if you put things underneath each other, they're ors. So it's a bit like flying through a computer game, a side-scrolling computer game, you know, those tunnels that you go through. You have to go through all the tunnels to get to the end of it, but along the way there may be some choices which are up and down. So that's how Boolean logic works in this query builder. So I'm going to make use of, you know, query building here, and just to check whether or not my vector query is doing the right thing here. So I'm going to take the word ice and I'm going to make it a not. So find me the documents that are close to this vector. Don't use the word ice, because I want to check what else it's matching. So if I exclude here, then we get a bunch of documents, 40 or so documents, talking about immigration crackdowns, deporting MS-13 gang members, all those sorts of things. So nothing to do with ice hockey or anything like that. So we can validate that that vector is doing what we want, and we can now probably dispense completely with the idea of using lexical search and just rely on the vector search here. And now that we've done that, you know, even within the subject of deportations and things like that, we can break down into individual instances or incidents. So within each one of these here, there's Florida sheriff says ICE partnership, only the beginning in illegal migrant crackdown. So Florida partners, blah, 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 blah. So it's doing all the things that we want still as subgroups within subgroups. So we used the cluster initially to clarify our intent, and now we can use the clustering to actually go down into individual events and incidents of things. And because it's by Elasticsearch and or Vesper, you can do all the sorts of things that you would normally expect to be able to do, like zoom in on bits of time and then add that as an extra level of filtering and querying and so on. Like. So that's binary vector clustering. Yes. What's what? The gray. Where am I seeing gray? Oh, that. Okay. So I thought what I'd do in there is whenever we've got a vector clause in the query, I'm actually showing the percentage of pixels that matched. It's a similarity score. So that's what's going on there. Yeah. So another very similar looking application, but this is actually using patent data. And what I wanted to show was the LLM-based tagging. So I'm going to start off with a vector query. I'm not going to do a keyword query this time. I've got a pre-canned example query here, which is travel guitars. So guitars you can fold up and pack away and stick in a rucksack or something and take with you. We can do the usual same sort of things, grouping by topic using the binary clustering, but one other feature that we have now is this tag feature. So we start off with a feature comparison matrix that has no features in it. So all we have is a list of patent titles and a completely blank set of columns. And we can either pick some tags manually and then check things as either being interesting or not interesting, or something like that to aid my investigation. Or I can ask an AI, an LLM, to consider this set of patents, these travel guitars, and look for discriminating features. So it's playing that game of guess who. So what's the first question that's going to help me divide this group up into two halves? And then after that, it thinks about what's the next question, and the next question, and the next question. And for each of them, what it's going to do to be transparent and explainable, it's going to tell me exactly why it thought that document X had feature Y using a piece of text. Because that helps me avoid having to sift through, a very long PDF or something. So the tags that have been added are: is collapsible, has hinged neck, has detachable neck, has automatic string manipulation, targets travel storage, blah, 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 blah. Right, so a feature comparison matrix is collapsible. So when I hover over that, the title explicitly says foldable and collapsible electric guitar. That's fairly obvious, but in some of these other things, it will have found something tucked away in the bottom of a very long abstract saying something about being foldable. And it saves me having to dive into that to read it, because it's brought to the surface as something that you can just hover and reveal that. So I might be interested in things that either have a hinged neck or a detachable neck. So I can pick those up as query clauses and drop them into my query builder. And here's where I'm making use of that OR. So ands go across, ORs go down. Strange little CSS artifact there. Okay, so we've used these features as part of our query. At this point, we're actually narrowing the set and focusing in on the features that we're interested in. And the other option is to show all these tags as a graph. And that helps illustrate which patterns have multiple things more easily. So you can then start to move these things around and drag. So if collapsible is really important to you, you could start to pull these things around and tease them out and find things which have other properties as well. And again, for each line on this diagram, we have that rationale from the LLM. We have the description of why did you say that this particular pattern had this particular feature, and it's there in the description of that feature and that particular pattern. So it's quite a heavyweight thing to do. It's not something you would offer on a very highly trafficked site, obviously. This is something for small numbers of power users. And it probably costs you a little bit if you were to ramp it up in terms of volumes of users and things. So just to summarize, these binary vectors, they are pretty good. I mean, I'll be honest, hands up, news headlines are very good for these binary vectors. I haven't had to worry about chunking or any of that stuff. By design, headlines are short, to the point, and about one topic and one topic only. So they lend themselves very well to a single embedding and doing this stuff. But it's very fast. It worked on my old iPhone, and it's perfectly good enough. LLMs can produce these useful human readable tags. They are a little bit quirky in that they don't always give you the same output each time. Part of the demo I was hoping to see tonight was one of the tags that would come out was saying maintain string tension or something like that. That comes up as a feature 7 times out of 10, and sometimes it doesn't, so it's quirky, but it does save you having to do a lot of reading and working your way through a set of results. The graphical query builder helps me pull all these things together. So clearly I'm not dealing with a sort of very curated and known set of content. I'm exploring. It's much more exploratory search, and I need to be much more flexible about how I combine query elements together, which is where this graphical query builder comes in. And these QRY codes, I found them useful. I think it's a new way of talking about stuff other than using keywords or clicking checkboxes. And it's worthy of being introduced to people as a new way of talking to a search engine, which is why I put that website QRY codes together in the hope that we can actually start to see some search interfaces start to bring some of these features together, make them more popular. Any questions?
Thank you very much, Mark. Good catch.
This might be a silly question, but I'll ask it anyway. That patent database, could you, in theory, use it to come up with inventions that haven't been patented because of the way it works? Or is that a nonsense question?
Well, I mean, certainly there's people in the patent office who are forever trying to invent new category codes to put things in boxes. So there's a group of people out there whose job it is to come up with these boxes, new boxes that they're going to put things into. And when you have an emerging new space and you throw all this stuff at the LLM and it looks at it and goes, has string tension mechanism, that could then become a new category code.
So the categories that a patent office, whatever country it's in, if they haven't categorized it,
if they don't have
in your system anyway.
Well,
in theory.
that's one application of it in theory. Yeah, I mean, because that's their job, is to look through the things and say, well, what's emerging as a feature that we haven't got a code for? That seems to me, like a viable option. What I haven't done, which I could do in that graph visualization, is to show which patents have which category codes and which LLM features, and look for areas in the graph where there's LLM feature codes that don't seem to have any kind of category code connected to them. And that's, a candidate for saying we need a new category code here, and it's probably has feature X. Because if you look at the category codes that the patent have, at the top level have something very simple, like physics, or and then biology, and it breaks down to that level, and then it goes down into lots more detail. So it goes about 5-6 deep or something like that. But they're forever trying to invent boxes for things, and what we have now is an LLM that's capable of saying, well, I know about the world, I know a fair amount about the world, and I think I've got some more boxes that you could be using here.
Is it based on any particular country's patent system?
Well, no, I mean, I could equally have put the news data in there as well and said, come up with features for these things. So basically, any set of data, like if you have customer fault reports or something, you could ask the LLM to say, well, give me some breakdowns of how to group these things. So 50% of your customers are having problems with connectivity or something, and 50% are, having problems with some other feature, so yeah, I mean, the applications of it are quite broad, I think. You're just asking the LLM to read a lot of stuff and then come up with ways of creating boxes for things. And that's quite a generic capability when you think about it. And it's what we've been doing manually for years, is inventing boxes to put things in, like the Amazon materials for shoes, all that kind of stuff. I mean, we're saying the LLMs can be doing some of this stuff. Potentially.
As an alternative view to this solution, I think it can also tell us the things which are not invented yet, essentially the categories that don't exist. Or it can be used to check if there's something that exists that I'm thinking about.
Right. Yeah.
You can have a go at catching it. Nice one.
My question is going to be very basic. It was just a clarification on your QRY codes. Is every colored box a 1 and every non-colored box a 0?
Right.
What happens then? Because you're saying we could make this a standard for different search applications. What happens then when different search applications have different sizes of embeddings? Do they change size?
So, and it's also the choice of model, right? Because you could have 1,536 dimensions, and so it's model dependent. So the utility of it, I think, is probably within an application and a deployment, but it's just getting people used to the idea. So it's not quite as universal as a QR code. Correct.
Got it.
It's not as widely applicable, but within a search interface, the opportunity for somebody to say, I want to search, but I don't want to use a keyword or a word. I don't want to have to articulate it in that way, but I can see a thing here that summarizes everything I want. To some extent, you can label it, so you can get significant keywords related to that cluster. But if you only have a handful of items, it might not tune into what it is that's genuinely the correct label or useful label for it.
Got it.
And my UI does let you label them, give a description to it. So you can do some stuff, but just generally, I'm trying to remove some of the magic from this stuff to say, be open about it. We're using vectors. That's what we're doing. It's basically doing similarity of these squiggly things, and it uses this number of pixels that are the same. That's the basis of the matching. Letting daylight in on it, basically, and saying that's how we're doing it. Hands up. If it's useful to you, knock yourself out, drag them, use them, whatever. But yeah, it's not trying to be black box about how we're matching, basically. Yeah.
Very cool. Thank you. Do I send it straight to the question asker?
Any questions over this side? Yeah, let's have a question.
When you are kind of getting the LLM to create the different categories, if you start adding new documents to your corpus, do you always have to start from scratch, or could you get it to say, oh, I've read all these documents, I've come up with all these labels before, find some more labels? I'm guessing it might break the algorithm underneath it.
This leads into a wholly interesting area. So it's almost political, the way this goes. So it historically, you had some database administrator somewhere who decided what fields we would have, what the values were, and everything else. What I just did was somewhat disruptive, because I, as a user, got an LLM, or I could have manually, created a new tag saying, has foldable thing. It doesn't really matter if it's me or the LLM that does it. The point is, that tag, how should I then share it so that other people can use it? Does the database administrator agree with me that this is a useful addition to the database schema and or metadata about these documents? So the politics of how you go about sharing these insights, whether they're LLM based or human observations about things, you run into this scenario pretty quickly, which is all this stuff was transient. And in my browser session, essentially, if I start thinking about giving persistence to some of these things, or automating the addition of it to new incoming content, then that becomes an issue and a question over data governance in a way. And how do we agree that this worldview is going to be shared by everybody else?
Quantum. It's not a category.
Yeah, but it's a tough one. And so at the moment, I have no opinion or subject on that. On that subject. Yeah.
Okay, do we have one more question for Mark, maybe?
Thanks. I think it's sort of an hierarchical color string, which you can keep exploring, and that's the way I look at it. Not just like the question is, have you looked at these binary vectors? Because I think one of the challenge here is to call the LLM to really come up with a nice description of that cluster, really to explain what that cluster means.
Yeah, I mean, one of the other things, I said I had possibly a third emergent facet to demonstrate. And basically, it's an old thing that I put into Elasticsearch about 11 years ago. And it's now in Solar and various other things. So let's go back to the news data. Okay, here we go. So there's a thing about Trump putting people in a prison in a Florida swamp somewhere. So if I pick that up and drop it there as a vector query, one of the other emergent facets that I've got is called significant text. So what it does is it analyzes the text of all these documents here, and it comes up with keywords or phrases that are statistically prevalent. So top one here is alligator Alcatraz. That didn't exist until a week ago. It's not in any model trained anywhere, unless it's been done in the last week or so. So I can pick that up as a query clause here, and let me just mute it for a second. So we're matching 131 documents here using the vector, and I'm going to unmute it, and I'm going to use it as an OR and put it there. We've got 7 more documents. So there are things that talk about alligator Alcatraz that the vector didn't pick up. And this is why I say, you need to have OR is more. You need to use multiple different approaches to match things. So the significant text or significant terms thing is capable of attaching labels to vectors, or any collection of results, but it's not always 100%. Yeah.
Wonderful, thank you, Mark. Wonderful, thank you, Mark. Please, Mark Harwood.